let's continue. So last video we stopped here. So we make our rotate according to Y XL. So now we have our another 2D shape after you press F6. Note this time we have only extrude by 1 millimeter. So for X area we have the 3. Now for Y part is 1. What we are missing now is the way to combine these two. If we extrude each of the shape by a suitable length and then superimpose them, the intersection of these two shapes should have exact geometry we are looking for. So that is the next tricky part. For the suitable length of the first shape, we need to estimate what the maximum height of the text will be. Here we can simply assume 3 times of font size will be the suitable, the maximum height. For the length we can take, so 3 times means if you write down the English character, is sometimes it's on these 3 different rows. So that is some idea. So with this value, now we can extrude the 2D shape and let them overlap using rotate and translate transform. So let's have this save, and then we make our another model number 5 and continue. So we have did. Let's go to text area. We still highlight this. For the first one, so we have a line. There is 3. So let's have this one. So estimated the length means is using the len. This len is the count the character of your text string. So here for us is 8 actually, times the font size is 10, then times 2. So that is the this parameter we are adding. So after the whole, so we are starting because you have a projection, so it's already back to 2D. So even you made the linear for this 2D, you go to 3D, but you downgrade that to 2D. So we can do another linear extrude. So we put this height as discussed is 3 times the font size. Now you have this one back to 2D, 3D. When you have this in 3D, then when you render that, you will get our arrow the warning, not the arrow, because it's mixing 2D and 3D. Is not supported, so we are ignore this 2D child. So, but you can have this 2D visible in this F5 preview, but you cannot render that. That is makes sense because that is from this the reality in the physical world. If you already have the 3D, how you can measure or view our 2D, because 2D actually is that there's no width. If both are 2D, does make sense, but now it's one 2D, one 3D, so that is the conflict. But let's do this one by one. So first we will rotate by this X part is on this the clockwise. So from this part, actually is from the stand back to the line. And then we translate this to 0, 0, minus 1. So I should have this removed and close up. This just try to see here. So we done with 1 the minute meter. So that is for the first one, and for the second one, similar. After how and the projection is back to 2D. So we need to linear height equal to estimated length. Let's see what happened. It's like this one, estimated length, because I have a typo. If you have if they don't find this one, they by default give you 100. So that is something they've tried to draw this. So I have this length. Length is the text is A times 10, and then times 2. So that means 160. So let's see. Correct. We have this one. That is too big. So let's see. So what's that mean? So we will have a translate. Translate on Z. So 0, 0 minus estimated length divided by 2. So it's down here. And then we will rotate. Rotate by y. 0, 90 minus 0. This should be coming if x is here. This should be also on this direction. So now it's on the another part. Note the use of the len. Len is we just use here. So let me save that and go to another file. We are almost there. Now we can use the Boolean intersection to create the intersection of this 2D. So let me see, these are the 2D. So we did this. Let me try to see module text. We have this one and the projection, and we will back to the 2D. So first is outside this, we have our intersection. This, and the intersection is coming to here. This one. Are we going to have this small one? Let's see. So projection. So have this one. But I think it's not like this. So what we have now, let me remove those. This side is we remove this highlight, but it's not correct. We indeed we get this lens, but looks like we haven't made this height. So let's double check here. First is let's back to our initial character, those const. So we will have OpenSCAD, and the font size is 10. And the font is this, and the stamp depth is this one. So that's correct. And then what we are going to see is double check this part on the text area. So the first one is, so we have the estimated length equal to length times the font size times double. That's okay. Projection, intersection, and first is 0, 0 minus 1 minus is 90. Oh, I haven't have this translate. So after linear, we should move this. Yeah, correct. Because we need to translate that the bigger one into this the thin one. So I haven't make that move in this negative y. So when we do this intersection, so they are not covered themselves. So let's see. What I'm doing is here is the two parts. So this part is getting the transparent, and what's the second part? Second part is this one. So is this fat one, this thin one. What's the intersection? Is their common one. So that is the thing. So maybe I can put that as well. Oh no, I can only put one transparent, but you can see here. So this transparent, and that is another thin one. So they are making those common. So I haven't have this one. So now it looks good. So it's the same like this. Let's save this and continue. So what I will do is I will open the number 05 and make this one should be missing. So here, so you can see here we stop here, but we should have our linear. This one estimated. Well, we should finish here. So from here, after rotate, we should have this sentence. Then they are cross each other. So this one, when we start to have this intersection, we will get their common one. So sorry for that is on this 05. We also correct that. Now we have this 06, let's save and save as to our 07. So we have this intersection and make this correct the text area. So we already done until here. So we uncheck this debug part. Let's return to the relief submodule and use our text area module to describe the relief background. So now let's see, we should add some more. The perimeter. So we have this depth, and we add our margin. Let's make that to 5. Margin of the text, and also we have stamp relief depth equal to 2. Depth of the relief subtract. And what we will do is we have this relief parts, and what we already have is this linear. Height is depth part. So let's give them our comments. These are the actual text, and the relief base is we will use this text area, and we will do the translate here. Show relief base. So first offsite. Let's check this offsite. Offsite delta equal to stamp margin. So the margin is offside means they will get the oldest this font size is enlarged per your margin. So if we see the margin is 10, then you can adjust this bigger by default is we don't have this margin, then is we starting from this 0. So it's inside here we can have 1. Can see here 2. So that is the margin. So we set this margin as 5. So that putting the text in the middle. So that is one, the transformation. And the second one is linear. So remember, these are currently, if we don't have that, our this row text area is 2D, because finally we did this projection. So they cannot render together with 3D. So we have to do this linear extrude and make that height like our 3D part is stamp, relief, depth. So now we convert this back to 2D, 3D, but because it's extrude from the origin space, so it's include your text. So you need to make your the text area down certain part. So what we will do is translate that 0 on X, 0 on Y, and then just stamp depth. Why we make this the upper is because this is the stamp. Stamp means you need to have this text from the vice versa, the direction. So you have this looks like is not correct. I should read the text from this part. But actually, if you have your oil and you make your stamp go to the paper, actually, is this part should be used as the stamp surface. So that's why is your stamp you need to have the text in the inverse the order. So that is the thing. We have our relief base. And module relief is, let's see what we have thing. Any change, text, font size, font, center 550. Perfect. So we are done on this 07. And let's see the next following part. We extend our module stamp with the perimeter this and the depth, which define margin around the text and the depth of this relief background. We model the relief background based on the text area and extend this with the transformation offsite. This transformation expand the subsequent 2D geometry by the perimeter delta or shrink the geometry if delta is negative. So that means if I want to make this minor 5, is shrinked inside. So that is depending on how this offsite delta means. Then we exclude our the expand text area to stamp relief depth, and the position is above the text. So that is the thing. The keywords you need to pay attention. So we need to make that higher using a translate. It would be nice if we could optional add a border to our stamp text. We can construct such a border based on the text area. So we have more the perimeters now. So let's give some border perimeter. So border. First, this is Boolean. So if we have border, then we give a true. So enable text border. Second one is we have a two character to define border. One is the thickness. Thickness give 2. Text border thickness. And we also give our border radius. It's from this the 4 these points on the end. Text border radius. So let's whenever you go chances press F5 to ensure you don't have any typo error. So for example, if I put this wrong input or this character here, you will immediately get an error. But if you don't do this in time, later on it's not easy to find the point. So we have this module relief. So where is our module relief? We have a text, and we have our relief here. So we are putting that inside the module relief. So relief base and the relief border. So this relief base, let's see, is inside the relief. So okay, so let me move that. But in the number 7, there's a OK, is you put that outside. But we want to make that inside our relief, the module. So that first I put this here and press F5. Then the difference is now the relief and the relief, the base are in the same color. So that is the better thing, because we don't need to make a different color on different the parts. Then let's move on. So we have this relief base, and after the text. So anything, let's see, translate, linear, offside. Offside now is we have our border or not. So if we have border, we will go to the border thickness, because we need to add our border. So that is one thing, is we need to add. So it's a check from the Boolean question mark. If true, then we have a border thickness added to this offside. Give our bigger offside. If false, then we give our 0. So now you should see here should be bigger, because we need to leave give us some space to draw this border. So that is one treatment. And then we have this text area, no change. So we don't have this debug required. And next, so we are starting to draw this border. So border is, let's say we are using the Minkowski, the transformation, but we can do this the step by step. So first we have our circle, and we have our the second circle. So these 2 circles, so we are using the difference. So that means we have these 2 big one removed from the smaller one. So let's make this one by one. And then the circle. First one is R is the border radius plus border thickness. Give our phase number equal to 36. Let's see what we get. Is get our this one. So let's highlight this, and we will do. let's focus on what's this one. So make this always check here. So and then we have the text area. So we will call text area. And let's see, so what we'll get. We build our text area. And what we will continue to do is we make our shift offside for this text area. So it's bigger based on the stamp margin minus border radius. And these two we will use as the make that Minkowski. So that means using this smaller, the second part circle as in this corner and make that as the rounded the rectangle. So let's see the effect for that Minkowski. So that, and we make this under here. So let's make this. You see. So now we have the radius of the circle is coming to these four parts. So that is the Minkowski's this syntax. And as well is we do another Minkowski. So let's see, we highlight this one. Excuse me. So this offside is the same, delta stamp margin minus border radius and the text area. The difference is here. R is smaller, just the border radius, no need to add this border thickness. So then we should get a smaller Minkowski's transformation result. So here. And what we want to do is using this one to cut this first one. And the left in the middle should be our text area with the text. So let's add this one, difference. And after this, Minkowski, and let's make here. You can see now we get a frame. So that is our border. And if we don't have that, this one is coming together with your existing one. And you can see here is not connect. We need to make that the linear extrude, because circle is the 2D. And well, we don't do this the linear extrude. So if we put this here, and if you press F, now you get conformation. You just have our 2D shape. So before this one, we should make our linear extrude. So extrude how height is the height equal to stamp depth. Now let's have this one. So we have this now. If we don't have that, is we are making that connected. So that is looks quite nice now. And don't care about this point, this area, because when you make the stamping, is only this Minkowski's effect round the rectangle, and the text will be put in that, and your text and this border are in the same height. So let me put that here. And last but not least is we add our check. So if border is true, we will do this. If border not true, then we will not going to make this. So let's put in that no change. And if it's putting here is false. then you don't have a border here. So that means our part for this border is working. So let's save and let's stop here, and we continue with the next video. Thank you.